So let's talk about what is an force. What is an force? The idea of force was first given by Newton in his first law of motion. It says when a particle is at rest, that is its velocity is zero, then it will always be at rest if no external force is applied on it. Or if a particle is moving with velocity u, it will always move with this speed if we not applied any external force on it. So force is something which changes the motion of a particle. It creates acceleration on it, thereby increasing its velocity, or create deceleration on it by increasing its velocity. Suppose a particle is moving with velocity u along this direction and we applied a force in the direction opposite to the motion, then it results in the deceleration, that is the force will deaccelerate the particle, so its velocity will gradually decreases. So there is the idea about force. So in short, that force is something which can create acceleration or deceleration. We relate force by this Newton's second law, which is F equal to ma. You can say that I'm just talking about basic preliminary physics, which we all know, but the problem is that do we really understand the definition of force? Let's begin a test. We all know that the conservation of linear momentum is satisfied whenever the external force acting on a system is zero. Let all the forces acting on the system resultant force is zero, then we can say that the linear momentum is conserved here. But suppose a particle is thrown upward, it attains a maximum height h, and after some time it will reach the ground with same velocity as it was thrown upward. So what happens in this case? Is linear momentum conserved here? Linear momentum conserved here? The answer is no, as the velocity, though the initial and final velocity before reaching the ground is same, but the velocity is not constant throughout the process. Its velocity gradually decreases when it reaches the maximum height and becomes zero, and then it turns back with increasing velocity as it reaches the ground. Because of course there is the gravitational force which is acting on the body, that is the external force. So here linear momentum is not conserved here. What happens is that total mechanical energy of the system is always conserved. When it gradually reaches a height, basically its potential energy increases and kinetic energy decreases. This is the conservation of mechanical energy. It says that kinetic energy plus potential energy is constant. So there is basically transfer of energy between the kinetic energy and the potential energy. Let us discuss another case. There is a small space here. Suppose 5 balls are hanging and they are in touch with each other. Suppose we pull this ball to a position, say A, and release. Let's say this is our reference line, the height is h. Then at this height the ball has some potential energy, and as we release, its potential energy gradually decreases as the height decreases and its kinetic energy increases. When this ball reaches this position and hits this ball too, its kinetic energy is maximum and potential energy is minimum. Thereafter the kinetic energy became transferred between these balls, and this energy as reaches the 5th ball, it acquires a velocity and move to a maximum position where the potential energy is maximum and gradually drops to this position, increasing the kinetic energy. So in the whole process, the linear momentum is not conserved if we look at a particle one by one. If it say that there is an external force in reaching to this position at a height h, so we can say that linear momentum is not conserved here. But if we look at the collision theory, when it reaches this position to collide with this, as a whole, in this system as a whole, we can say that linear momentum is conserved. So is there a confusion about that? Instead of having an external force, the linear momentum is conserved? It depends on how we define a system. If we define the system as a whole, then of course the linear momentum is conserved. But we individually treat this particle as a system in velocity changes time to time, then the linear momentum is not conserved here. But as a whole, the momentum transfer between this ball and reaches to this place. So answer is, in this process the linear momentum is not conserved here if we look at the particle one by one. Okay. Let us discuss another phenomena, which is a simple collision. Suppose there is two particles, one with mass m1, velocity u1, and another mass with m2 and velocity u2. Let's u1 is greater than u2. Obviously this particle is faster than the particle 2, so it will collide with the particle 2. In this process, we can apply the conservation of linear momentum. That is, before collision, the velocity of the particle u1 is fixed. Just before the collision, its velocity doesn't changes. So there is no acceleration, so we can say that there is no external force. So the total linear momentum of the system before collision is this, which is constant. It has some numerical value. After the collision, m1 attains a velocity v1 and m2 attains a velocity v2. Then after collision, the total linear momentum is also constant, equal to constant. According to linear momentum conservation, this initial and final momentum is constant here. So we can say that m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. One can say that the velocity of the particle is changing. It shifts from u1 to v1, and this particle changes the velocity from u2 to v2. So one can say that, is there any force which changes the velocity? The answer is no, because there is no force acting on the particles. The velocity changes because of the transfer of momentum between these two. Before the collision, the velocity was u1, so it was u1, it never changes, and its velocity was u2, so it remains at u2 and it never changes. But after the collision, the velocity changed to v1 and the velocity of the particle changed to v2. We can numerically put, let's initially m1 u1 was 3 and m2 u2 was 2, so sum is 5. After collision, the momentum decreases. m1 v1 is 2 and m2 v2 is 3, so again 5. So as the momentum of the first particle decreases, the momentum of the second particle increases, as total momentum is conserved. So only the momentum transfers between the particle. There is no external force so that which can changes the velocity of the particle. So here external force equal to 0. One can say that, then how the velocity of the particle m1 and m2 was initially created? one can say that we given a certain force so that it creates a velocity on the particle m1 and m2. But if there is a force, there must be acceleration. u1 can't remain fixed, it must changes with time. As it doesn't change with time, so we conclude that there was no forces acting on m1 and m2. So external force is 0. So linear momentum is conserved here.